Morning children, here we are back again. Physics class 8, physical quantities and measurement. Today we are going to do determination of density of a liquid. Okay. So last time I told you how you can find the density of a regular solid. Because density is given by the formula mass upon volume, so you need to know the mass of the regular solid. The regular solid means solids with proper dimensions. Then you can find the volume also. Based on these two quantities you can find the density. Irregular solid, I told you how we can go about it, right? You need to use a measuring cylinder, you need water the preferable liquid, okay? Then you need to tie that irregular solid, like let's say a piece of stone or rock, anything like that, which has got jagged edges. Initial level of water, dip it in, final level of water, minus it, all those things. Now we can find the density of a liquid also. So for this also you would need a measuring cylinder only. Better if it's a measuring cylinder, okay? So first you need to find the mass of the measuring cylinder, okay? So we'll call that M1, right? So whatever value, x grams, whatever, right? Then you need to put the liquid inside this measuring cylinder. Then you need to weigh that measuring cylinder again. So you find this will be x1, this will be x2 grams. Okay, so how do you find the mass of the liquid now? So this is the mass of the empty measuring cylinder. This is the mass of the measuring cylinder with the liquid. So mass will be M2 minus M1. That means measuring cylinder with the liquid, the weight, basically mass. Okay, then remove from that, subtract the mass of the empty measuring cylinder, and then you get the mass. Okay, and for the volume you just need to see till where, because measuring cylinder has got a lot of gradations, you need to see. Okay, so just remember meniscus of the liquid, sometimes the liquid will become like this, okay, sometimes it becomes like this. Okay, so if it's like this, you need to see the lower from where it touches. Okay, you need to take the reading. If it's above, you need to take this reading, right? So you got the mass, then you got the volume. Okay, thereafter let's say milliliter. Okay, then you find the density, mass upon volume. Since you know the mass, you know the volume, what is it? Let's say x grams. Since you know the mass, then you know the volume, you just calculate it, you'll get the density of the liquid. Okay, so these are the various ways in which you can measure the density of liquid and density of a solid. Okay, now we go to a topic called relative density. Okay, now if you look into your book, if you go to okay, since I don't have a book in a topic called relative density, I've just taken the picture shots. I think it's page number 9, if I'm not mistaken, because I've cut out the page number out here. If you see, it says like you will find that the density, if you take the density of aluminum, okay, if you take the density of aluminum, I think it's given in the book as 2700 kilogram per meter cube. Okay, I'm not writing the unit. Okay, it's less than the density of iron. Density of iron is given in the book as 7800. It's less than the density of iron, but more than the density of ice. So ice will be water only. Okay, so okay, let's write ice on this. So 920. So aluminum is more than water, lesser than iron. Okay. In other words, we can say that the aluminum is lighter than iron but heavier than ice for the equal volumes. That's very true. So it will be practically impossible for us to memorize the density of each material to compare its density with another material. In other words, to avoid such confusion, scientists compare the densities of most substances to the density of water at 4 degree Celsius. Understood? Because water has maximum density, minimum volume at 4 degree Celsius. Understood? Water is a very strange liquid. There's a concept called anomalous expansion of water, which we'll be covering later on. Very strange, because ice floats on water. Technically speaking, the solid of a liquid should sink in the liquid when it's been put, but in the case of water, it floats. Okay, so that's what the book says. So in order to avoid confusion, scientists compare the densities of most substances to the density of water at 4 degrees Celsius. This is called the relative density of a substance. Okay, so the definition given in the book is the relative density of a substance is defined as the ratio of the density of the substance to the density of water at 4 degrees Celsius. Understood? So whatever substance that you will find the relative density, you have to compare that with the relative density of water at defined as ratio of density of water at 4 degrees Celsius. And another term used for relative density is also specific gravity. Okay, so I'll just give you the formula. So relative density of a relative density of a substance, and that will be RD is equal to density of the substance upon density of water at 4 degrees Celsius. Okay, so density is mass upon volume. Okay, so for equal volumes of substance and water, relative density, hardly the same thing, can be written as mass of substance upon volume of substance upon mass of water at 4 degrees Celsius upon volume of water. Okay, so since the volume, as it says, for equal volumes of substance and water, so volume gets cancelled, and then what remains is mass of substance upon mass of water at 4 degrees Celsius. Okay, so this is volumes of a substance and the water are same, they are constant, that's why we remove them, they cancel out each other. So we come to the final formula of relative density. Okay, thus relative density of substance can also be defined as the ratio of the mass of a certain volume of substance to the mass of the same volume at same volume of water at 4 degrees Celsius. Okay, so as relative density is the ratio of the same physical quantities, it has no unit, right? So so we use a relative density bottle to find the density of our water. Okay, so it's on the next page. Um, it can be using the relative density of a liquid can be determined by using a special bottle called the relative density bottle. This bottle is also called the specific gravity bottle. It's a small glass bottle with a stopper having a fine capillary tube. Okay, so it's got the stopper. It has got a very fine capillary tube. Okay, and this is the stopper. Okay, it has a fixed capacity which is generally marked on the wall of the bottle. Okay, when the bottle is completely filled with a liquid and the stopper the excess liquid rises up the capillary tube and drains out. This ensures that the bottle always contains a fixed volume of any liquid filled in it. It can be used to determine the density of the liquid. Okay, so this is just an introduction for you, because in higher classes you'll be doing more of the relative density. In this class you're not going to do. Okay, so with that we come to the end of the topic for today. We'll be continuing more with hydrometer and all. Thank you, children.